All right, so it says the table here shows a relationship between the number of phone calls made and the number of tickets sold during fundraising campaigns. So the theory here is if I make enough phone calls, I'm going to generate so many tickets, right? And so we're trying to do like a mathematical model. So think of this, and if you look at the graph, this is like my x-axis. That means that's the independent variable. And this is like my y-axis. This is what we call the dependent variable. In other words, the number of tickets you sell depends on how many phone calls you make. So think of this as like x comma y. So the first thing they want us to do is draw a scatter plot. So what I'm going to do is I'm going to plot the point 6 comma 13. So this is like 6 comma 13. Right? If you think of it in terms of x comma y, or you could think of it as n comma t. So then the next point would be 9 comma 15. So I'm just going to plot that. So I'm going to go over here to 9 and guess about where 15 is. Probably about right there. So this is like 6 comma 13. This is like 9 comma 15. All right, next is 10, comma, so I'm going to go over 10 and up 17. That's going to be there, 10 comma 17. This would be like 11 comma 19. So I'm going to go over 11 and up 19, which would probably be about right here. And then this will be like 12 comma 22. So I'm going to go over 12, up 22. Why does 613 look off a little bit? All right. Then the next one's going to be 1425. So if I go over 14, about 25. Okay. And 6 comma 13 is the only one that's like way off. So this is like 14 comma 25. So that's my scatter plot, right? So this is like 9, 13. This is like 10, 17. This next one is 11, comma 19. This next one is 12, comma 22. And then the last one is 14, comma 25. And so we've done that. It says, does this show a positive or negative correlation? So correlation means it looks like a line. Positive means it has a positive slope. So if you look at this, doesn't it look like they're pretty close to a line? Yeah. So we would say that this has a positive correlation. Now, if it had a downhill slope, you would say and it looked like a line, you would say correlation. Sometimes when you plot data, it doesn't make a line. It's just all over the place. So correlation means that it's like a line. Doesn't have to be perfect, but it's pretty close. And positive means that it goes uphill, right? When you read it like a book, positive means a positive slope or it goes uphill. When you read it like a book left to right, it goes uphill. And it says to describe the relationship in the data. Well, you could say the more calls you make, the more tickets. I was going to use TIX, but we'll be academic and say tickets. You sell. Now it says use 2 ordered pairs to make a prediction about the line. So what we do is we arbitrarily, that's a fancy math word that says we just randomly pick stuff. We arbitrarily pick 2 points that we want to calculate the slope and go through the stuff for calculating the slope of the line. What 2 points do you guys want to use? What's that? Okay, I think you said 915. Let's do 915. It doesn't matter. What was the other one you wanted to use? 10. I'm gonna stretch it out a little bit. I'm gonna go all the way up here to 14 comma 25. Now you guys may have used different ones, so our final answers will differ a little bit, but what we're looking for is the slope is going to be very similar to the same, and the y-intercept will kind of be the same. I imagine that most people, because see, most of them are here, you could do the first one and the last one. I'm going to double check the work anyways. So we're going to call this x sub 1, y sub 1, x sub 2, y sub 2. Oops. Y sub 2. And so I'm going to find the slope for this, and I'm going to say y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, and that's going to give me 25 minus 15 all over 14 minus 9. So I get 10 over, that's not 10, why did I write a 6? I'm going to get 10 over 5, right? So it looks like a slope of 2. Now, to find the equation of the line, we're going to write that into y. Man, I'm really running out of room. So I'm going to write this really small. I'm going to say y minus y sub 1 is equal to m times the quantity x minus x sub 1. I'm going to plug in 2 for my slope, and then x minus x sub 1, which is 9, and then y minus y sub 1, which is 15. Distribute the 2 through the parentheses. I got 2x minus 18, y minus 15. I'm going to add 15 to both sides. I get y equals 2x minus 3. I believe that's the equation on the line. And then it says make a prediction if 20 calls were made. So that's saying, what will this be if I have 20 calls? Well, you could do this 2 ways. One way is to plug it into the equation. In other words, the number of tickets I sell, which is like the y, right? Number of tickets I sell, is equal to 2 times how many phone calls I make, which is 20 minus 3. What's 2 times 20? 40 minus 3 is 37. So if I were to extend this all the way over here, somewhere over here we would have 20 comma 37. Okay. Now you can verify that by graphing. We do have time. Let's try it and see. So I'm going to go in here to Desmos, and I said that my equation was 2x minus 3, right? And then I said that if I sold 20 tickets, I should, or if I made 20 phone calls, I'm sorry, I should sell 37 tickets. I got to zoom out a little bit. See how that works? Let me take a screenshot of that. I don't know why. There's literally no room in the notes. And we'll put that somewhere over here. Okay.